All right, so I'm going to record this. Some people are in class right now, so we can share this. And also, if you guys need to rewatch it, you're more than welcome to. And I'm going to start sharing my screen. All right, cool. So let's start this off with, so this is assignment 2D. So yeah, the first thing we wanted to cover for this was our extrude. We want to extrude our floors. That's the first thing we want to do. The reason why we want to do this is from originally in assignment 2B, we took all our floors and we lofted them. Now, if we loft it and if we use that loft surface and we took our rays from it, took some view rays, our sight lines will be perpendicular to that surface. And actually, it would be perpendicular. So we're going to get rays that are going to be shooting off from the sky and shooting all around. In fact, it would pretty much be like a globe of views. And that's not really how we behave. Just because I'm on this floor, I'm not going to be looking up. I'm going to be looking, straight out. So that's why we start this off. So what we do is we take all our perimeter floors, and we're going to explode them. And what that does is it breaks them up into line segments. They could be made up of, it's actually made up of 4 sides. So when we explode it, it's going to give us 4 segments of each floor. And we want to extrude those segments to get a nice straight surface. Now, even though we're not going to be using these surfaces as part of a 3D model, we just need those surfaces just for our the logic behind this, the logic to get those views correct. So that's an interesting, a difficult thing for when you script these things, is sometimes you may have to beat around the bush to create what you really need to do. I need to take views, but I do have to create some geometry just to set up the logic of that. So we're going to get these perpendicular, these surfaces. We're going to extrude them up. We're going to extrude them up in the Z direction, and we're going to be referencing our floor-to-floor heights. Again, including if our first floor is off. Our first floor is actually like 18 feet. But again, that part doesn't matter. You're really not going to see the skyline on that first floor. So that's why it's just just grab the typical floor-to-floor. And then we get our extruded profiles.
Wait, can I stop you for just a second? So I think one of the things I was trying to do for that one is make sure I got the right one. I tried to pull from the copy floors, I tried to pull the series to compensate for the first level and the second level and all that stuff. So you don't have to do that. You could just do 14.
You would probably want all your floors. So I pulled it from, I pulled that from scaled perimeter floors. Yeah, you probably want your scaled exterior perimeter from there.
You just basically have the perimeter of the one that goes in to compensate for the sides, right? And then the other one's going to be your series.
Yeah.
That you created. Okay.
Well, so this one actually came from the previous assignment. We copied our floors up with the series. We moved them up, and then it's the rotated floors that we're taking, and then it's the perimeter, and then we're scaling it. So it's after the scaling is when I grabbed it. After all the manipulation that we did with the series, once it's pretty much, those are the floors that are going to dictate the massing of that. The line work, that's the component I took.
Okay, because I didn't actually scale my floors.
Though, then that's fine. Then you just take it from your rotated floors.
Okay, got you. That's why I wasn't, okay, awesome.
Now that's really important to take it. It's really important to take it from these rotated floors, because what we're going to do is this value for our series, for our rotation, is what we need for Galapagos to read. That's the value that is going to be changing all the time. So it's really
it's not the slider angle that we hook into Galapagos, or?
Yeah, we're gonna grab. No, it's weird. The Galapagos is looking for slider or like parameters that it needs to test against. So it's going to take the view rays that we have, and we're going to shoot out all these view rays, and these view rays are actually going to be controlled through this. Well, they're all their beginning points are based off the massing of the tower, and this parameter controls the rotation of that tower. So Galapagos says, okay, I'm going to be reading the length of all these view rays, and I'm looking for the most amount of length I can get, and I'm going to add them all up. And it's going to compare those numbers with this value. And when we move this value, when this value grows and shrinks, our view lengths are going to shrink and grow. And that's really important, because that's the value it's going to be comparing. It's going to start learning, saying, okay, I was programmed to find the maximum numbers, and I'm going to learn through these evolutionary principles that the more I increase this value or decrease this value, the lines are going to change in the maximum way. And I'm going to slowly learn from that to give a solution that has the highest results.
So I'm running mine right now, and it's spinning and doing its thing, but I hooked into the degree of rotation. So that is not it looks like it's doing what it's supposed to, but.
So if you just put it in, like you had a slider right here.
No, I went back to my original one and found the degree of rotation, which is, I don't know where it is on that, but is that it?
This one, yes. So this one is the 3D rotate with the series that's going to rotate each floor plate. Here, do you want to show yours? Do you want to, let me see if I can pass this back to you.
Then I'm going to cry. Hold on a second. Can you see that?
Oh,
Yeah. Yep. So yeah, it's running through a whole bunch of different options, but let's see.
Does that look right? Am I doing this?
Well, we gotta see the script, see how it goes, because sometimes it will. I mean, mine was doing something similar to that. I think we just gotta check the script, make sure it's going right.
Okay, hold on. I just let me see. See if I can bring it in here. Can you see that?
Yeah.
Okay. You want me to bring it down to the?
Yeah. Let's. So let's see what your Galapagos is connecting to.
So it is going. Sorry, it's really laggy because it's doing its thing.
Oh yeah, yeah.
I'm trying to zoom in. So it's connected to the rotation. Actually, I guess that's what you were showing, the rotational degree. So I guess mine is just it's called something else. Okay.
Yeah, yep. No, you got it right. So it starts at 0, and then yeah, as it it rotates each floor a certain degree. Now, one thing controlling the amount, like that range for that slider, I see goes up to like 0 to 50.
Yeah.
So we can we know when it gets to 50 degrees, the whole thing is just like a super tight spiral. So we might want to minimize that range, so then it starts to find the answer a little easier. Having a building that's such a tight rotation, that's going to be, I don't even know, you're going to have your surfaces overlap, and that becomes very difficult to build. And there's we should probably keep, there's a little bit of reality to it that we need to control that rotation.
So like go up to like 30 or something like that, or like 20.
Yeah, I think I can't remember what I put. I think I actually put mine at like 15 or something. It wasn't too crazy.
And that would speed up this whole genome project thing.
Yes, it would. It actually speed up. It would get you results faster because now it doesn't have to compare as many numbers.
Okay.
Hey, I'm sorry to interrupt, but I'm really not that far along. Sorry.
Okay, yeah.
Well, just even a side note on that, I couldn't even get that thing to connect.
Me neither. That's
to it. It wouldn't actually snap into its place.
Okay. Well, all right. I'll let me start sharing. We'll work our way back to that.
But can I just clarify something real quick? So you're saying that the scaled exterior perimeter, because I just want to make sure, because that's like the beginning, so I want to make sure the inputs are right, is going to be whatever the endpoint is of your rotation, correct?
Your
like your rotated geometry.
Yes, that rotated geometry. That what we did. Yes, so that is the thing that we are manipulating to get our Galapagos. So to get our final form. So yeah, it should be that shape, that scaled exterior perimeter. That is the shape that we reference.
Perfect. And then the floor to floor height, I just want to confirm on that. What did you pull for that?
I think I did the 8. I think I did 18 the first. So it starts at 18 and then it does 14 after that.
Okay, and ours was 20, so that's fine.
Okay.
So I'm pulling it from the series, right? I just want to make sure I got that right. Okay, cool.
If it's
I got that
20,
right.
that works too.
Okay, perfect. That makes a big difference in terms of what I'm seeing now.
Okay, good, good. Yeah, there's sometimes it is the smallest things can throw you off. In fact, I was just kind of like wrapping my head around this, and I was like, what the heck? I was getting errors, and I was like, why is this not working? I literally just did this a few days ago. Like, why is this not working? And it's like one little number wasn't connected, and it threw the whole script off. And it was actually that radius, that view radius. I forgot to connect that, and it was like, and the whole thing just lit up as gray. And I was like, it is finicky. And this is also really advanced stuff, guys. So you guys are already, I'm really happy that you guys are being proactive and asking questions and are here, because yeah, this is some really advanced stuff.
So in that section where we're extruding the floors, the floor to floor height is just basically one value, and it's applying, so it's literally 14, correct?
We're just going to make
it. It's not like a list. It's not a series, because I think that's what I did before is I plugged the series in first and got this like crazy, didn't even look like my building anymore. And so it's literally just 14.
It should be a, let me show you my screen really quick. It should be a list of 14 numbers, because we are taking, Oh, it is I'm sorry, I misspoke. It is just one single number because it's taking all these segments, all 224 segments, and it's extruding all 240 of them 14 feet. So yeah, you're right. It is only one.
Okay.
It is only one value.
Okay.
Okay.
Right, because I was originally trying to, I guess, take the series and explode and extrude it with the series. And it worked, but it gave me like crazy, I guess, it would extrude one like 136 feet.
Yeah. Yeah. So it would, it would take all those values.
Yes.
It would take all those values and times it by 240. So you would have like thousands and thousands of surfaces created.
Right.
Okay. Yep,
Okay.
Yeah.
Okay.
So the process that you guys are going through is exactly what I go through. There's like, I wish there was an oh shit button sometimes on this program because I'm like, oh, I did not mean to connect that. And I just crashed my computer because it just computed millions of things.
So what is it doing? Like it takes the explode and then it's, because when you have the explode, I understand that it's like creating basically 4 different branches, or excuse me, 56 branches with 4 lines per branch, right?
Yes. So then it should yes. So there it is. You'll have 4 lines for every 54.
So then how does it change with the extrusion? Because then it just looks like you lose like each of the lines. So I'm so confused on what happens with the next ones. Because I threw a panel on the extrusion one just so I could see what the output was, how many surfaces, and the branching is way different. So I don't understand that.
So those dotted lines are normal?
Okay, mine does not look like that.
Yes. Yeah. So that, it just took, so it just made it into a line like into an untrimmed surface.
Oh, okay.
And the dotted lines are normal. So when we have a solid line, it means it is one list. It should just be one list with several, just like this. So it should just be one list with several items in it. But as soon as we explode it, it's now saying, okay, hold up. We no longer have one branch. We are now branching off. Now each one of these little stems now has a branch. And maybe this could help. If we did, here we go. So this is a diagram of what the data tree looks like. So so that's our data tree when we put it in. So it's like, that's just one list of values. But as soon as we explode it, now we have 4 values in one list and 56 lists. So now our tree just got much more complicated. And so now you see it just branched off. So now there's 4 values for every branch. So yeah, it grows very much. And we know it's 4 because there's 1, 2, 3, 4. So it gets complicated. But this dashed line is normal. It's just representing, hey, I'm making branches, I'm branching out. So this part was one part I wanted everyone just to kind of forget. I believe, I'm not sure if I connected this. Yeah, so this one should be, I should probably have just connected this. This is really just something that is behind the scenes. Sometimes Grasshopper is stupid, and it errors out when there's overlapping points, or it sometimes has a tough time reading objects that are at 0 or overlapping. So this is just something that it it deconstructs the domain and reconstructs it in just a very small value. Again, this is just something behind the scenes that I don't want to get into. It gets fishy, but this is where we should get into, where it's like, okay, now we have our perpendicular surface. We need to start creating points on that surface. Why do we need to start creating points? Because we need a starting point for our line of sight, because our line of sights are going to be defined by lines. So that's where we chop up the surface using this domain. So it should be our extrude surface to our domain. And again, this is just something that we want to generate points along the surface. So these values are all about how we are going to subdivide this surface. So U and V are values that you use they're coordinate values for a surface. So when it says subdivide in a UV direction, even though UV is equivalent to X and Y, UV is referencing a surface. So that's why it's a UV. Could say it's exactly the same as X and Y. It's just, like I said, it's just different nomenclature for surfaces, the math behind them. But once we divide that up, we now have a surface that's broken up into points, and that's our output. It's our points and our vector. So vectors are important because that vector is actually perpendicular to our surface face. So those two values are really going to help out. We're also going to amplify this. Again, it's the same logic behind this. I think I apologize. We probably should have just like drawn the points, but we should be moving our points to there and amplifying it, because we need to move them up again to get them out of overlapping each other. So all right, now that we have our points, we got our points set up, we have all our starting points that we need. Now we need to start getting our views.
Okay.
So when we generate our views, we're going to reference at the center of our site, since that's it seems to be whatever site you pick, that will be the center of it. And this is just a set radius that's going to be determinate, and I just put 4,500. So it should generate a nice large circle around this. But
is it the center of the site, or is it the center of the building?
It should be the center of the site. Not the center of the building is going to be, since our building is going to be really tall, the center of the building is going to be way up here. So we want it right on the site, the center of the site. So it's like its coordinates would be in the Z direction would be 0.
I think I did that to just pick the buildable area part of it, not like the extended property lines.
Yes, that's fine. If it's in the center of the buildable or the center of the actual site, that's fine. One of those will work.
Okay.
I have a question.
This has to be at 0, like the bottom plane.
Yeah. What's up, Megan?
So I have it plugged into the center of the buildable area, and it's pulling from the origin, and I keep playing with it and it's changing points and whatever, and it's still stuck on 0, 0, 0. Is there something in the background that you can think of?
If that's the case, I would delete it and recreate it. And it's really just a point, it's just a point parameter that I renamed.
Yeah.
So
okay.
If it's doing that, I would do that. If it's still giving you issues, let's grab a point really quick. There is a option in these.
Mm-hmm.
So let's say it's like I really don't want that point there. I can right click this and I can do set or manage point collection.
Okay.
And it gives me a list of points that I can manipulate. So I can actually add more points or I can delete them.
You can delete origin.
And so then
Okay.
it clears that out, and you're back to a parameter that's empty.
Okay, cool. I'll try that. Thank you.
Yeah. So now that we have our, we have our points of our building. Now we need to get the endpoints, the points that we want to. We need the endpoints to actually draw that line. So we're going to shatter, and what shatter does, it's going to take our nice little circle, and it's going to break it apart. And there's a reason why I put this here, reparametricize, is a lot, and this happened a couple times during the sessions, is like sometimes the curve, the domain needs to get reset on it. So sometimes if I draw a nice curve, I want to bring this in. I might just do a little test evaluate curve. And I just need a little one slider here. So I get my little point. But see, like I'm moving the slider around. This is supposed to be 0 to 1, you know, but I'm moving my slider and my point is hardly moving. And I'm like, that's not right. This whole point is supposed to be defined by 1. So that's why I have to reparametricize it. And what it does, it sets the whole thing to a 0 to 1 domain. So then I can, when I do this, I have full range of it. Again, it's one of those things that it's just Grasshopper. It's kind of like it needs a little extra help. It's dumb, but that's why we have this. And we're going to shatter it, but we're going to shatter it between 2 points. And what that will do, that's going to isolate it. So when let me show you, I'm going to draw a quick point right here. Set 1 point. So we got our circle. So when we shatter it, it's going to shatter it between, we're going to hold this here, and we're going to hold our shift. Actually, we're going to show it right there. And we're going to, just as a test, show you. So even we can start to see, we can highlight. So these are all the other views that we don't really want, even though they're fantastic views at 56 stories up in the air. The client wants just that one specific view. And so that's what that shatter does. And now we can actually change that if we want to do, like, change our start point. We can actually have this thing grow, or we can shrink. And this is all up to you as the extent that you want it. But you notice as soon as you move this back to 1, it flip-flops. So it's based off of 0 to 1 start and end point. So you can't just say, oh, start point at 1, end point at 1. Well, that means 1 minus 1, it's going to be 0. But you know, you start your end point a little lower, and it starts to grow. So again, you guys can adjust that as much as you want, but this is just there to help define the views that we wanted. The next is, what do we do with the other views, and what do we do with our key views? So our key views, we need to rebuild this, and by what it essentially does is it breaks it up into in just segments. And I only did that because it's easier for the mesh to mesh. If it doesn't, it can be kind of a messy object. So I just rebuilt that, and we exploded it and extruded it so it's these segments. Again, this is
So
this
they're
is
rectangles instead of a curved surface.
exactly. And then we extrude it up, and then we need and then it ends with converting our surface into a mesh. And why do we need to have it as a mesh? It's because Mesh Rays is looking for a mesh. That is the only reason why we're using meshes is this component right here. This component is the logic behind this is I can only work if this is a mesh. That's why we're converting all this stuff into a mesh.
And why Mesh Rays again?
Mesh Rays, it's one of the there's a couple components we can use, but this one actually is I felt this one was a clean one where it gives us the outputs are points, and the outputs are these true false statements. I mean, we can write this a lot of different ways. Just for me, mesh was the one that made sense to me the most, and that's also the component I'm familiar with. The funny thing is, you could write a script very similar to this and not convert this to mesh, and you could probably make this to a BREP. But it was just, in my case, I was just familiar with this component.
I have a question. I'm sorry.
No, go ahead.
I have a question about the inputs for the height of the circle view. So in one instance, I put like for the mesh for the other views in city context, I basically use the series again, getting up to the height of 776, but that didn't seem to work for the key view. So do we plug in something from before, or do we just go back and look at our panel and pick the highest top? Like mine was 776.
You can do that. You can do whatever. It's as long as it's equal or higher than your building.
Okay. So okay.
Yeah, that's why I picked for these. I picked 1200 just because they were. I knew those were values that were going to be taller than all the options that we generate for everyone.
Okay, great. That's because what it was doing with the key views is that it was actually building a series.
Oh.
The wall was building a series for some reason, but it was the same plugin for the other views, so it's really weird.
Oh, okay. Well, that's kind of. But no, it should be as long as it's taller than the building, should be fine. And then once we have this set up, we're just going to do the same thing for this one, or not the same thing, similar to it, but we're going to extrude it, and we are going to then combine it with our city. So this is our city context. This is everything. This is probably this is other than actually running the Galapagos script, this is probably the most intensive component because you have to highlight all of this. Probably the best way to do this is, the way we organized this was all through layers. So it's easier just to do existing buildings, right click on that and select objects. And then we can just go back to our Grasshopper, right click it and say set multiple BREPs. And now they're all in Grasshopper. How many are there? All 1,933 BREPs are in Grasshopper now. And we can actually preview that and we'll see. Okay, we have everything in Grasshopper. The next thing is we're going to also mesh that, and we're just going to join everything together. Even though, we're going to join it. In fact, I don't believe it will still be. Yeah, you can join. Yeah, it's good to join it, and then we're going to merge it.
I was confused on that, the logic of the merge part of it. Like, why are we taking the other views and the key views, merging them into views? I think I got confused with the logic here.
So when we merge it, it's going to stick it in, it's going to have it as, here, let me bring up the, so when we do this, we'll have our panels. It's still going to, it's going to give us still a series of meshes. I mean, we wanted everything as just one list because we're going to, I'm trying to remember why I did that. Because we want to, I know I wanted this all as one, everything as separate items. So it's easy to call out.
So those are all, like, there's 10, but there's actually 11. And the one is the one that we want, or no, excuse me, the one is the combined one that we don't, those are like the other views. And then the other 10 are those rectangular surfaces that our key views are hitting, correct?
Yeah. Yes.
So are we gonna like remove one of those at one point? I think that's where I got a little lost in the next section.
So when we merge them together, that's where we get that's where this comes in. When we start to get into our views, because this is where, so we merge everything together, and then we took our views and we did the mesh rays. So it tells us, we did the mesh ray, and it combines it gets all the meshes. It gets our points, our intersections that we wanted. But we needed to duplicate this data because we had to compare it to something. So even though it's saying, okay, shoot out all the rays, it hits the points. All right, and it's like, okay, so what? Which views are better? Well, I need to compare it to something to tell it that this view is actually better than the other view. So that's why we had to duplicate this data. And that's why we had to, it's why we reference the views again. And so we're putting it, and so we're gonna duplicate it by the number of views. So so that's where it's like, okay, it's gonna test each one of those meshes. And so we have that number to compare to, because if we didn't multiply it, it's going to duplicate it the correct amount. So once we have that, so it should jump to, and the way these are lined up, it's really like, all right, what's our mesh to intersect? Well, that's
what is normal views representing? Vector normals. Vector normals.
Vector normals. That represents the perpendicular, that vector that's perpendicular to that surface. So that is the actual direction of the view. So all that is referenced right here. So all this work that we did here is all for that little parameter, for that one. So it's looking for our mesh, our directions. It's looking for intersects a mesh for infinite rays. So that means it's looking for points. So we need this, it's essentially saying, give us a starting point so we can shoot these meshes. So that will give that's our starting point. And then it's, okay, give me the mesh that I'm testing to. So that will be our views, because our views are considered meshes. And so then the duplicate is, we want to duplicate our starting points. and we want to duplicate the number of views. So when
Okay, and I know you said why, but can you explain it again, why we duplicate it? I know you said it, I just didn't grasp it.
So we need to duplicate it. So we have, so with this gives us all our point intersections, right? So it's given us all the things that are hitting the objects.
Uh-huh.
But we need a comparison for that. We need it to, so it's saying, okay, great, I'm hitting something, but I want to know if what I'm hitting is good, or if I'm hitting, or what am I hitting is bad. So that's why we duplicate it. And we're going to duplicate it, and this value will come in handy when we start to sort through our views. So we have a value that's saying, okay, I'm hitting stuff, and I have a value that's saying I'm not hitting stuff. And we need to understand what is good and what is bad. So when we have our dupe views, once we have this set up, we're looking for, we need to start to sort through this stuff. We need to say, okay, what are the points that are, what are the points that are good? What are the points that are bad? So the nice thing about mesh rays is the output, the second output is a Boolean statement. And I like that they even said, it's a hit or a miss. It's saying, I'm actually hitting something or I'm missing something. And in this case we want, and this is where we're going to use our call pattern. And call pattern is it's taking a list and it's going to take out items based off a true false statement. So if I had a series component, and it's going to go through intervals of 2, and we're going to have 50 of them. We have a panel. All right, so here's our little list. Actually, we'll just do it. So here's our list, right? So it's just a simple series, but if we do a call pattern and we call out that list, and we're going to do a Boolean statement. Whoops, Boolean toggle. We're just going to set a pattern as false, false, true. And to keep it clean, we want to merge this really quick. And we don't really have to merge it. We can always just throw all 3 of them in here. We'll just keep this clean though. So what this is going to do is this creates a pattern, right? It's going to take this and it's going to remove a number, keep a number, a number, keep a number. And that's the pattern. So we take that and our panel. There it is. So it's going to, so it starts off as remove a pattern, remove a number, keep a number. Remove a number, remove a number, keep a number. God, that's a tongue twister. Remove a number, keep a number. So that's how we get the 16, 32. But we can change it so we can, let's delete this. And see, when we did false, 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 it's like, all right, well, it's all false. But if I do true, I'm going to get half that list. If I can make it a really complicated pattern if you want to, and then it gives us that. So that's why we use a call pattern, because it's saying, okay, all the points that are duplicated here, all the duplicated points, get rid of the things that are hitting. The points that are the intersected points, get rid of those. That tell it's a hit or miss. So call out all the misses. You know, the view weight. Now we need to know which ones we need to apply a view weight to the ones that are actually hitting. So we want those. And what this does is, oh shoot, I'm sorry, actually, I'm sorry, I think I explained the duplicate wrong. Let me double check this really quick. Yeah, my bad. So I'm sorry, we're duplicating our subdivide points. That's why that's why we're duplicating. So this outputs an intersection, and that gives us the endpoints of all our lines. And that's why we need to duplicate these points, because we need the start points. Now we can't just say, okay, take all the points, because that's going to give us the wrong number of endpoints with the wrong number of start points. So that's why we had to duplicate this. And that's why we're calling it out. So we get our duplicate points, which are our start points, our points intersections, which are our endpoints, and that gives us our line. And then we have our view weight, which needs to get called out, because we need an equal number of all those to work out. So we have to have like 50, we have to have our 50 values for 50 values for our duplicate points, 50 values for our points intersections, and we also need values for our view weight. And so to start the logic of, we're going to combine all the line lengths, or to start understanding the line lengths, we need that value. So we're going to just take a simple length component, which creates a length, and we're going to plug that into our sort. What this does is it organizes this for us. It pretty much just helps us organize this list. It pretty much just organizes it. It's once we want to.
Can I back up for a second? Sorry.
Yeah.
So the H in the mesh rays, that's the one that we're going to use for all three of those calls for the pattern.
Yes, because
okay.
The output is going to be all. And see, even that symbol, when it's a half colored circle, it means a Boolean statement. And even says empty Boolean parameter. And then when you look over here and we look over the P and it says, oh, it's looking for a Boolean statement. Now, right now, these things, their default are false, false, true, true. But that's just the default that comes in when you make it. You can plug it in as anything you want it to be. But so we want to get these statements as a true false.
And then your line that you're creating is from the duplicate points and the intersected points, correct?
Correct, because these dupe points are our starting points that have been modified, and our point intersections are our hit points that are modified.
At which point should you start seeing the rays to know that you've done it right? Is that the very end, or?
You should be starting seeing them now, because when you combine these two, because that's when you actually created a line.
Okay, I don't.
So yeah, let me.
It looks like everything's right, so I don't know if I turned off something or.
Let me double check really quick. So yeah, yeah, you should be getting, so with that one component that turns on all the lines, but these lines aren't the lines that have the weight that we need them on.
Okay.
Yeah, they're all the distance to the perimeter, correct? Or
Yeah.
to the circle.
Yes, they should also, if I change that circle parameter, these should all change as well. But this is before we sort it and apply a value to these lines, the weight value.
Okay. It just looks like everything's right, so
It might be in the very beginning here when you start getting your points. Afterwards, you can share your screen. I'll
okay.
take a look at it. So we have our line. So this is where we sort it, and we want to start calling these out. Now we want to start grabbing. We're going to take our list item. So we're going to just, and it's exactly what we're going to. Now we have all these lines. We have the points that make up these lines. Kind of weird now. We actually have to take these lines and we're going to recreate these lines based off the weighted value. So that's where we take our line lengths, our line, and our line weight. And at the end of the day, we need an SDL line, which an SDL is looking for a starting point, a direction, and a length. So we're going to take it's looking for, what's our line? So we'll have our line, and we're going to take the endpoints of those lines. So the beginning and end point, and that is going to give us a vector. So the key one is, this is the key one, but a lot of the stuff is really just right here because we need a direction to give it to give this SDL line for it to be formed. So we're going to take a line and we're going to break it apart. And so what creates a line? 2 points. And this component right here gives us an endpoint or a start point and an end point. And when we have a start and an end point, that is actually a vector. And so create a vector between 2 points. So it's really just plugging in the start point and the end point into the vector. And the output of this is a vector. I wouldn't worry about the L because that's the length of the vector. You could actually put the V into direction and L into the direction, and you would create a line from there, except you need a starting point. But the length of it, we need to apply our weight to. So that's why we have this multiplication to it. So once we connect these to the multiplication, because that will give us our length. And then that will actually generate our lines that are weighted. So as soon as you connect this, it will start to know, okay, these lines that hit the area that we need it to are now going to grow by a multiplication factor. And then we're going to take our curves, and this is just a curve component, and a curve component, we're going to grab the length of all those rays, and we're just going to add them all up. And we're just going to tell Galapagos, okay, we're going to take this and we're going to add up all these curves, and we're going to try to find the maximum, and its fitness value will be the result, and the genome value will be that rotation. So when it starts to run, it should, double click it, we want to set to maximum, and we want to start our solver. It's going to take a second for it to initially start up. Now, we can, to really help, you can adjust these. So if you may have like an old computer that's really slow, I highly recommend clicking on this. Do not display any genomes in the Rhino viewport. So what that would do is that just won't show all these different options. It's just going to, the screen won't move, but in the background, all this will calculate. This is helpful because it's not trying to, it's not telling the computer, okay, create an image for every option. It's just going to say, don't worry about the graphics card, just compute, just do this, compute this out. That's going to help. The middle ground one helps because it's saying, okay, don't worry about any of these, just show me the best one and compute the rest of them in the background. Only show me the one that's the next best. And then the slowest one is, can show me every possible option. And we do this, and it will, and it does play a pretty big factor on it. I've had it where it's you can get some faster results by doing this, by going the faster speed. It's just not as fun as looking at it. Now you get to see all the different options. And for me, I mean, I have an i7 Intel Core i7, so the speed may range. Some of you guys might be faster, some of you might be a little slower. It all depends on your processing power of your computer. And
you have a component that turned red. Is that expected also?
Yeah, let me, it might be the mass addition. Let me stop this really quick. It might be the mass addition. If that's the case, that's fine. Mass addition is hold on. Just a sec. Hold on. Let's see. I think everything should be going good on this one. There we go. I think, no, so far on my end, it should be fine. If it's, if it is glowing red, let me know. If it's the mass addition, this is a funky, I've had this thing glowing red and it still works. It's just, sometimes it has a weird air to it, but it still works. And you can always double check it by throwing a panel tool on it. But yeah, that's the general logic behind this. Like I said, this is really advanced stuff. So, but you guys are doing great. So don't sweat it.
I have a quick question.
Yeah, it seems like you gave us the introduction to the advanced Galapagos.
It's funny it took me a long time to grasp the idea, because it's weird because it's already like you're already scripting, which has you're using a lot of brain muscles that you're just traditionally not used to using. And then it's like, okay, but now you have to make up a situation and compare that logic to what you just worked so hard to make in the first place. And you have to compare it with the result. It's just like, it took me a long time to grasp it. But it is something that is happening all over the place. And I think the biggest thing about this technology that's going to change the most is the user interface, because that's the one thing that is discouraged. That's the reason why this technology isn't going as fast as it is. It's picking up a lot of momentum, but it's that user interface. And especially with Grasshopper or Dynamo, the biggest thing I hear is like, you have to know all these components to create these logics. And it's true. This isn't like a traditional 3D modeler where I know 5 commands and I'm pretty dangerous. I can make a nice box and I can start cutting it and chopping it and make something cool out of it. It's like you really have to create that logic. And how do you create that logic? Well, it's all about knowing all the components and what you can do with that. And so it's difficult. And so a lot of the software companies and even Grasshopper are changing the interface of how people interact with this. This still isn't going away, but a lot of what I do at work or discuss at work is how to get other people more involved in this. And so what it is we're making custom interfaces for them to interact with. So they don't see these wires anymore. They see a nice little menu, and you have all these nice slick sliders that you can move around. You don't have to worry about, these. You don't have to worry about these sliders anymore. They'll have a nice sleek one, and we'll throw a logo up in the corner, and they don't have to ever see these wires. But again, it's that's the biggest thing that's changing. But yeah, this is some advanced stuff. But you guys, I'm really happy that you guys are being proactive in talking about this, because I think this is going to just really help in the long run.
Can I ask you a quick question?
Yeah.
How can you go over, after you run these things, how to go back in and pull the pictures out, the JPEGs out of it? Because I just did that other one and let it run through, and then I tried to get the information from it and ended up, losing it. So
yeah. Let's see. So once we get this, you run through the solver. Actually, I'm just gonna let this run for a second. I'll show you once. Oh, go ahead.
No, I was just gonna say I also changed my slider to 15 rather than 50, and it's going slower than it was before.
Yeah, that one I don't know.
Yeah, I don't know either.
Yeah, that one's strange. Yeah, I might want to let that one think for a bit. Once this thing, let's see, once this thing starts cranking out a generation.
While we're waiting, as these projects go on, if they get difficult like this, can we set up a weekly extra, one of these things?
Yeah.
So that we can go over stuff?
Yeah, we can. And so the way this class is structured is this first half is all about just learning the tools.
Yeah.
And getting everyone familiar with it. The second half becomes more like a design studio, where it's essentially, okay, you guys are free to do what you need to do. I'm going to give you a scenario. It will continue with this tower, but it's like, okay, now we need to start creating a parametric surface and start, we have the model. Now let's start creating a parametric wall. And you have to use Grasshopper or Rhino to create parametric pretty much a parametric building and 3D print it and start rapid prototyping this skin. So it's going to be after spring break, it's going to be a very different pace.
Cool. Yeah, I might need some refreshers too, because like I think some of the other ones, once I get it, I don't know if I can replicate it later.
Right. And this one will, like I said, I'll probably guide a lot of just some of the scripts, a few of the ideas of how we would use this script. But yeah, the idea is now it's like, okay, this is the technology. Now this is how you design with the technology, and how you design a parametric wall or parametric surfaces that's changing and all these different variables and is twisting with the tower. And then how to use the 3D printer to help feed that information and create that loop of process, that fabrication, tweaking the script, tweaking the script.
Will this video be available later tonight or?
Yes, I'll post this up tonight. Yeah, and I'm a few times, I'm surprised how long it takes on YouTube to post, but I'll get this up tonight.
While we're waiting for this generation to pop through, can I just go back to the apply view weight? I understand that the line prime, the line length prime, and the view weight prime, those are all going into the list to create, an item list. And then you're taking the line weight and the line length and the line, and you're timesing those to create a line length to create towards the line, right?
Right.
Okay. I'm a little confused about what is what's going into the end. So I know you have a start and you have an end, but I don't understand the curve that's being used to go into that. Is that the result of the two lines as well?
Let me hold on just a second. Let me stop this.
Sorry.
No, you're fine. I'm glad you got perfect timing. This works out great. So
It came up.
no, so it's we're gonna stop this, but just to answer the question, once let's run. The first generation always takes the longest, but once you get this going and you have I'd say this is probably the best option. Or if you want, pick ones lower. If you just aesthetically want something different, you can click these and you click reinstate. And it may take a second, but that changes the parameters in Grasshopper to get that reinstate. Once you click OK, then you can go back to your assignment 02B and you can bake that massing model. So if we go back.
So for each one of these, you have to go back and bake it.
Yes. Yep. And I'm just, for this assignment, I'm just looking for one. Just give me the one, that one optimal solution.
Okay, so you're not looking for 12 separate bakes for the 12 iterations.
No, so it's just let the thing run for 12 generations and then boom, give me the best one out of all 12 of those generations.
Oh.
Okay, cool. That's good.
Okay, good. Yeah, I don't need 12. I just need one. Just give me one option. So then once you get and this is I'm sorry, not that one. We want the massing model. That is the one that the massing model is the one that we're going to bake. And we're just gonna, usually you have a nice layer that's set up for it, but we'll just bake it. And there it is. There, out of this one, this is the option that came out to be one of the better ones. And remember, these lines that I'm showing are not the correct lines.
I was gonna say, because mine don't look anything like that.
Yes, yeah. So so it should be looking like something like that.
Oh, mine seem to cover more of the radius. I mean, I have definitely some long ones, but I have little ones throughout the whole radius.
And that's fine. And like there isn't there isn't a wrong answer. This just for this my scenario is just in the generations that I let it run. This was just the one that came out. Yeah, sometimes I saw a few options that it's like the rays were all almost evenly dispersed around that
Yeah.
circle, and it's like yeah,
Okay.
if that's what it keeps on giving me, then in this scenario that's fine. In reality, I would let the thing run much longer. In reality, I would let it run for a few like overnight, and then of course I would always double check and rerun it a couple times and just get a different variation to it. The the nice thing about this, and this is why Galapagos is such an interesting component, is that in this scenario, there really isn't a right answer. There's a right answer logically, but it's like, okay, find the greatest number. But in design wise, it's, it is, could the tower tilt, 15 degrees more and get a view? Yeah, but this is just giving us, this is building our credibility, building the reasoning and the meaning why the form is the way it is. And that's the crux of it is, you set up this logic and you let it run and it gave you an answer or gave you something that's really close to an answer. And that's very hard for someone to dispute, because a lot of times people will, most of the time people will dispute your designs, and you're going to have to defend them. And with this is just a really powerful tool that also has some great logic to help defend the design, to defend the design integrity.
So I still wasn't able to connect my genome.
So the genome is
It wouldn't snap to it.
So the weird.
Oh, I go the other way.
Yes. So that is.
All right.
Yes, it's weird. It's looking. We're not inputting. It's looking for the things to test.
Okay. Thanks.
So yeah. So this one will go all the way to. I don't think I don't have a assignment 2B, but yeah, that would bring it all the way to that slider. Or you can also click on. So if let's pretend I could just click on this, because it's kind of a pain to drag it all the way over. I can just highlight this, right click on it. I can say select its sliders. It'll automatically go to it. You can also, if you have a really complicated script which has a lot of different parameters, you can just right click and say all sliders. It'll go to all the sliders in the script. Another great one, which I didn't cover because I've actually had recently, it's weird, recently I've had a lot of bad luck with, it keeps on crashing, but this is actually a really great script, is a gene pool, which is, it pretty much just takes a whole bunch of number sliders and combines it into one. And so you could set all these different sliders, and then all you need to do is connect that, and it will know to test all those variables as well. And sometimes in some scenarios, you will have a lot of variables to test. And so it's, so this is a great tool. And also you can always change it up. So a gene count, we can add, 25 of these. And we just created 25 sliders that we can all test at once for this. So it's a powerful little slider. But again, I had some strange luck that it would crash on me. But okay, I'm sorry. I go back to the SDL line. So Yes. So we have our line length, and we have our view weight, and that's how we apply the weight to it. So we're going to take our line length and we're going to multiply it by our view weight, because now that we know that it's saying, okay, now that we know the ones that are actually hitting the views that we want to, we're going to multiply that. And that will give you a large number that will go into our line.
What about the vector? Is that just from their points? And this is probably on the recording. I was just asking again.
No.
The vector I know is going to go into the direction because of vector, but the points, ingoing points for the vector.
Yes. So when we have a vector, it's looking for base point, tip point. Utilize up. Yeah, you don't need, that's a false, so we don't need that. We're just looking for 2, so we're just.
Oh.
I
I moved them around, and I think that's what screwed me up because it's like out of order.
So if we mirrored this, if we actually did endpoint to begin point, that the line is just flipped.
Okay.
But yeah, we just keep it in the same direction. Oops.
So I was trying to I was trying to match like, so when it said like start and start, I did the same things, but I guess those aren't used together. Okay.
Yeah, it's just it goes back to that vector where it's just, it needs a direction. So it's just, give me a direction. Well, how do we define that direction? It's going to be defined by a start point and an end point. And so that's why we had to make this endpoint and input it into a true point vector. Any more questions?
I just had a quick question about the logic behind the view weight. I set it up right. It's just, just because everything was pretty much already set up, but I just didn't. I mean, you had everything all together. There wasn't really much to input there, so I was able to connect it. I just don't really. I know it's just. Is it multiplying the line? Is that what it is? Like.
So what it gives us it's essentially given us I want to phrase this. I mean, it's setting up that zero instead of multiplying this by our view weight by a really large number. It's more of just keeping it within a certain range, so it's not like, I mean, already it's blowing out quite really far out. So this view weight just helps keep the numbers a little more manageable. Actually thinking about it, I'm like, wow, I could have really simplified this and not have all these components. But yeah, that was really what, when I was writing it, what I was thinking, it was just like, I don't want to spit out these weird factors. So that's why. I mean, I am getting it's. Yeah. Why am I? Yeah, I think I could have simplified this a lot easier. So, but yeah, I mean, it should just be something that you have we have our typical domain, and then we have our range that defines it, but just keeping it within. It's saying like, okay, if it's a key view, it gives us a little more magnitude, and it gives us a 7 magnitude, and the other views, it just, okay, multiply it by 1, keep it the same. And if we didn't do that, it would give us a multiplication factor it would multiply all the views. It would, no matter what, if it was hitting or not, it would multiply it by a factor, and so your views would grow really far out, and it would just take longer for it to compute because they're all multiplied by a factor that's greater than 1. Honestly, I think I could, I think I probably really could simplify this one. But that's also one reason why I filled most of it out, because I was up against the wall.
Like one of those wave your hand sort of things, right?
Yeah, it was one of the things. It's one of those things. It is part of it, and especially with some of this stuff, you come across Grasshopper, and sometimes it's just like sometimes you use this series command, you create this little shape, like a little box, and you use a series command, you move it so you have all these boxes lined up in a row, and then you want to extrude it up. Well, sometimes you're gonna get 8 out of 10 of those are gonna be right, and you're gonna get 2 of them that go in the different direction, and you're gonna be like, what the heck? Why did this? And it's somewhere in the logic in Grasshopper that that somehow the normals were flipped and it extruded in a different direction or something like that. You have to go through this whole little tangent, and it's exactly what this is, a little tangent, just to deconstruct these curves and get them flipped to have them and recreate them in the right order, so they extrude all of them in the correct direction. And that's just the nature of programming too.
Yeah.
It's like you're gonna get these weird scenarios that the computer is just like, you're like, dude, this computer is so dumb, and it's just you have to go through these testing, and you get into these pitfalls. The nice thing is, it's just using it as long as I've had it, you kind of find things that you just know aren't going to work, and you have to plan ahead, and just you have these little tools that are workarounds that help you out. It's interesting. It's like, the best case scenario is like if you had a group of people and you had a whiteboard and you told them to draw a box, and every one of those people are going to draw a box differently. Even though you told them to draw a box, they're somehow are going to draw it they're going to draw it in a different order than the other person. And sometimes the computer does the exact same thing. It will draw 16 boxes correctly, and sometimes it will just misdraw that other one, and you're not. So you just have to create that logic to make sure that it's always going to do that. It doesn't come out as often as I'm describing it to you, but it sometimes does happen.
I have a question concerning the views.
Yeah.
When we duplicate the views, we're still pulling the views from the same source, right?
Yes.
In the same mesh. So, okay.
Yeah, so it should just they should just draw, just like that. Sometimes you'll have points where this thing, well, I'm sure assignment 02A had some of those components that have a lot of branching out to do. I'm sure they're, when I was flipping through.
Okay.
Yeah, shoot. Look at this one. This one's already branching out a lot. So, it's just how some of the parameters are drawn out. So, yeah.
I got another question.
Yeah,
I went through all that stuff, and I chose, like the best looking genome out of them, and it looks nothing like, well, it looks similar to yours, but it does not, it seems like it avoided that open space in my circle. And so there's no views that are longer like yours are. Is there a reason for it? Is there a spot in this code that not?
You might have these switched. You might have these flipped around. I'm not sure. If you want to, you can share I can stop sharing, you can share your screen. That might explain it if it's trying to get all the other views instead of that opening.
Now those two curves I added those two curve components. I added. I mean, we probably didn't have to, but I added them.
Oh, you did you did like this?
Those two, because they're not in the original class file. So.
Oh, so you did something like this? Like you added a curve and then you connected it there?
So I added. Oh no.
Oh, my bad. Actually, not like that. There we go. Oh,
yeah,
not like that. That's fine. That's fine. You're not. It's just saying, hey, I'm gonna connect a curve to a curve, and I usually do something like that just to keep things consistent. Like view weight should connect to view weight. So yeah.
I mean, I don't think mine are backwards. I have my I have key view to my +1 there, and
so if you preview that, just you could always test it. It could be a couple things. It could be did you run it all through the different genomes and stuff?
yeah, and it just none of them were long. It was like I said, it almost like avoided the opening in the circle. So like it did everything. It did a bunch of different views around to different points in the circle, but it did not do anything past that opening in the circle. So all my sides are the same length, and they don't extend out where that opening was. It's kind of weird.
Here, you mind showing you? Here, I'm gonna stop sharing. You mind showing your script?
Sure. You see that?
So when you yeah, can we hover around the curves really quick? Yeah, there you go. So you have your key views. Can you click on your key views really quick? Yeah, that guy. Can we see the Rhino?
Like the spit out?
Yeah, the Rhino viewport.
Yeah, hold on a second.
We also might have to unpreview that list item.
Okay. Oh man.
Oh no, you're good.
So that's kind of what I'm getting.
Okay, can we okay, so it is hitting up that there is a little bit on that corner.
So that down here on the where the X's are here.
Hold on, you're sharing your you're not sharing your screen.
Oh, hold on.
You're good.
Okay, so down here where the X's are.
Yeah.
That's the opening in my circle, and it's like in all of the genomes it like avoided that area completely.
Okay. So let's you mind if I take control?
Sure.
Let's see. I forgot how I did this.
You go to the thing. It's in the remote control up at the top of the.
Yes. View options. Request remote control. All right. Is your Galapagos running?
Yeah. No, it's not running. but it's,
Oh, there we go. Hold on. You can control. For some reason, I'm not able to control it.
It says you are.
There we go. Now it's going. Now it's cooking. So, export it. Ooh. Sure. Then we got that. So we got now the interest. I think we got our 2 points. We're multiplying that. Yeah. I think. Well, it's being multiplied. What's it being multiplied by? Well, why is it getting multiplied by A? Okay, so it's giving us that value. And its output is. So we're gonna grab a panel tool. It might be. See, right now it's all ones. Okay. Because that's one issue, because everything is being multiplied by 1. So that means it is value to revamp. What's the value? Hold on, let me yeah, I'm gonna give you back control really quick. Let me check. Because I think
I have my remap a little different than his.
yeah, that's what I'm thinking is because all your values are the same. Oh, where is that? 2D. Oh, that's actually so your domain should be it should be range connected to T or range connected to V, and then domain should be connected to T. And your domain, let me should be between 1 and 7.
what it is?
Yeah, and which that's yeah. So there you go. So it goes V to T, and then your R is that. Can you grab a panel tool and put it to your weight?
Put it to my weight.
Yeah, there we go. Yeah, so there we go. Should be 7 should be the max. And then why is it good? It's spitting out a whole bunch of 1s. And when I connect it, I get a lot of 1s too. But you should get a few. Oops. Can you do me a favor? Grab a after that you call all your line weights. Oh shoot! You should Yeah, so after your call,
Yeah.
grab a bounds. A bounds component.
This thing?
Yes. Connect that to it.
To which one?
To the L of your line weight.
The view weight or yeah.
View weight. Sorry, yeah, view weight, not line weight. And right click on the eye. Say flatten. And now connect that to your panel tool. All right, and scroll all the way. Let's just scroll through that because you should be getting values. Null. See, that's the issue. Is you're getting null values. Let's keep scrolling down. Yeah, see, it's so average. So that's why you're not getting any multiplications because it is hitting something, but then it's saying it's null.
So it's hitting that open area and computing it there.
Yeah, so where it's saying where it is a hit. So if when it's not a hit, it's just okay to multiply it by 1. But if it is a hit, it's saying okay, multiply it by that range. So you have your hit, your line weight, your hit, your points.
Is it happening with the rebuild and mesh key views? Because when I just changed mine like his, mine switched to 1 too.
Okay, it might be up there how it's in the mesh.
Where up here?
Yeah. So we hit the mesh. Oh, there it is. So your explode, rebuild, explode, your segments are being extruded by the vector, or by the V. It needs to be height of the circle in the Z direction.
Height in the circle in the Z direction.
Yeah, so take that V, where the Z is, plug it right into the D of the extrude.
Oh, up here.
Yep. Now disconnect that H. Now you should be good.
Okay, so back here.
Now your values are, yep. So scroll down, you should be getting some value. Yep.
Yeah, okay.
Now there's the 7s. Now you should be getting, now if you go back to your Rhino viewport, your line should be big.
Oh yeah, okay. Sweet.
Yay, that's a good catch. All right, can I get some rays? Can someone help me get some rays?
Yeah.
Thank you.
That was the whole reason of me emailing you.
yeah, it does. Take it. Let's see what you got.
All right. That was a good catch, though, on the other one. All right, let's see. I think this is it, yeah. So actually, I should pull up the Rhino real quick. Hold on. Share that. So this is what I have. I mean, I probably have a lot more things turned on. Sorry, it's a little slow with the zoom on for some reason. But you can see I don't have any rays.
Okay.
You can see I do have the perimeter around. I do have the broken up here, the lines. I changed my view because it was just doing this like weird thing where mine was out here. So I put it over here. But I'll share my, maybe I'll just bring this over here. Hold on. Can you see the script now?
There it is, yes.
Okay, let me just make it a little smaller, I guess. So I have never seen rays, so I think it's somewhere screwed up in the beginning, but I don't know, are you able to take over or were you having issues with that?
Yeah, let's see, let's request.
Oh, I gotta approve, okay, approve.
Cool. There we go. It always takes a second to.
Yes, it's waiting to control screen.
There we go. So we have our scale parameters. Well, the first thing is there's, yeah, so we want to connect our extruded profile. We want to connect that
Oh,
to that.
okay.
There
so
you go.
what-
You're so close. You're so close.
Dang it. Okay. All right. Well, I think that yeah. All right.
Okay.
Good. I did have a the red line at the very end, but I don't know if that fixed it.
Let's see.
Like way to the right.
This one.
Oh no,
the
that's wrong now. Okay.
sort.
That wasn't.
Yeah, so this is why everything has to be at, even though, wow, it's still being able to generate.
That wasn't red before.
Yeah, that's usually that, if that's red, none of this works. So let me double check that. Let me just unpreview this. That means it means that there's something else, because this value, there's some of these values that they all have to be the same. 797.50. This one, yeah, see, that one's off. So there's something here, and this was the exact same thing that was happening to me the other day, where I was like, why is this not working? And it was because there's one little thing that we're missing. But you got a little further than I did, because it's actually generating, holy cow, curves, but they are huge. And
Well, I
it
wanted
made,
curves.
yeah, those are really long. And that might be extrude is 18. Okay, that's fine. Your mesh, I'm looking for generate circle. That's correct. Let's find key in other views. It is buildable area. There, buildable, your center. Yeah, that's fine. Oh, I think I'm getting into. It is, we should remap. I'm looking for that remap. Oh, here we go. So this one, why is this? Okay, so this might be one issue, is that the mesh is connecting into key views. We don't.
Oh, yeah, no, I didn't know. Crap. Yeah, that doesn't go there.
Yeah, so that I think that once we do, there we go. We still get something, but we're getting way more accurate readings. Actually, why? So it might be just one of those things that it still works. 950, yeah, it still works. Which says, it's like my professor, when he was teaching me this, he was like, sometimes he's like, you can have red components. You just can't have multiple red components, because then it's like, he's like, this is bleeding. You can't have too many, you can't bleed too much.
Well, that wasn't red before. There was a line at the very, very end, like all the way to the right.
Got it.
Where going into the glop goes. Oh, that's not red anymore. Okay.
Yeah, so that should be good. So it is computing. it is computing right, but
Okay.
the issue is it's just the values that it's inputting aren't correct. Isn't the it's supposed everything I said everything's supposed to be even, but I think if you're still getting it, it should still give you your output. So those are normal points here, points there. Your views should be going to the same thing. This is your, I don't think this will matter, but we'll just make that there. But that actually, no, I don't think so. Sometimes you get finicky things like that where it won't work. Even like some of the display options, there's some bugginess to that. Which yeah, it's like I said, there's sometimes some weird stuff that's it's trying to mix programming with visual programming. So there's always some things that get lost in translation. But I'm not sure why you're still getting.
Should I just delete it and like re-put it back in, or?
Yeah, maybe that might be it. When this happened, it was something. It was back in the mesh area where it wasn't computing things correctly, but it seems like this is key view shatter radius. Yeah, that's correct.
I mean, I did change my viewpoint start. I don't know if endpoint. I don't know if that was.
Oh, that's that should be it. Yeah, I'm not sure why.
Okay, that's fine. I'm happy I have rays because then I can give you a picture.
Yeah, that you got raised. So yeah, let it think, and it shouldn't think too long. Like I said, it took mine like half an hour to think through things, and which is not bad at all. Some of the other people, like we're gonna later on we'll work with daylighting and doing simulations, and those the ones that that we're gonna try are pretty quick. They don't take too long to calculate, but some of the really intense ones that other firms use, like there's a local architecture firm here that has a whole lighting group integrated to them, and the person who runs it, uses Grasshopper, and he's like, yeah, they use these simulations and they run them for days. And so it's like because they got to get them really accurate, and so some of these can go for a really long time. But in this all our scenarios are going to be pretty quick. But yeah, if it's still running, I mean, if it's still running, it should be fine. Now, if you're still having issues, let me know. But yeah, just from the glance of this, like it still should be good. Views, yeah, list length, number of times. But if you're still having issues, let me know.
Okay.
But right now, it seems like it's functioning right. It just may be something. It just may not like something.
Me.
in the background. Yeah, I'm not. Yeah, it's strange that it's doing that. Your line mesh rays, you're creating your lines from it. Yeah, that's strange. But you got the lines, like I said, if anything else happens, let me know.
Okay, awesome. We'll do.
Great.
Thank you so much.
Yeah, no
Thank you
problem.
so much for taking the time to do this tonight.
Oh, no, that's what I'm here for. So thanks for, yeah, asking questions and yeah, so is there any more questions?
Yeah, mine's doing the same thing, but it's affecting the things down the road, so I think it's more of a problem.
Okay.
I can't figure out the illustrate.
Okay, so it is sorting. Let's see. I'll request control. Let's see. So we have all the H's there. We have our line. What is our length is 84.7, 47, and it's that one. Okay. So if it's that, looks good. Let's see. So if we do our key views, so this may be when something like that. And center gives us, okay, that's good. Radius. Let's move this over to 1. Oh, there we go. So let's see what this may actually meet if this, there's that. That's our other views. So we're just going to shrink this up really quick. This may be it. So you got the lines covered. So we have that little spot there. So that's what we want. So I should key views. Yep, that's right there. So that works.
Doesn't look like they're being multiplied.
What's that?
It doesn't look like they're being multiplied.
Yeah, that's it. It's something with yeah, that's a the output there. But let's see. Let's do that same thing. Let's do the bounds. Let's see what that is. Goes there. We're going to flatten that so it's a little easier to read. We might have the same thing. Oh no, we're getting some multiplication. Here's that, yeah. So we should get, and let's just turn off the end point. So we have our line. But it doesn't like, oh, that should be right. Why is it data conversion number to curve? Is this really a curve? Yeah, that's a curve.
Are we supposed to have line length and line going into the C?
Line length. Oh yeah, see there's right there. Yeah, exactly. We're gonna disconnect that. We don't, there we go. Now we still have that sort issue, but it seems like it's working though. But at least now we're getting, the lines are longer when we're looking at the views. I think points, subsurface. That's our surface domain. Yeah, so that should be all correct. I think it's just, I think that should do it. It's just the same problem as Michelle's, where it's, that sort is still leading. And I'm not sure why it doesn't like that, because it should be hitting the right amount of stuff, unless, what was it, 1935? Let me see. I doubt that's that, but you never know. Yeah, you should be fine. But as long as, like, it should, now if you run it, it should be good. It should hit those, and it will start to learn that it will grow from that. I'm just not sure why these multipliers aren't going the way it should, because we're getting those values. Like if we cover there, yeah, those are all our values, and it's at maximum's at 7. So that's where the only thing is 68,000. Yeah. But if it's still an issue, and if it's like really screwing up the results, let me know. But it should be good now. I'm just curious on why we keep on getting this sorting to be red, and why it's not detecting, because we're using all the same booleans. Unless views, 11 views, and we're multiplying that by our points.
Elise, were you still able to run yours?
I haven't tried it yet, actually.
Okay.
Okay, I think try it. If it's still, it should, I mean, already it should work, because we're still getting the logic. I'm just looking back at mine, and it should, yeah, views to points, and now let's hold on, let me see. Yeah, all graphs. Yeah, so you should be good. I'm just not, you might want to just, I wonder if you delete the sort and recreate it and replug it back in and see if that works. That might be one.
I just tried that. It didn't work.
It didn't work? Oh,
Yeah.
shoot. All right. But yeah, if it's still working, it should be, then I think that it's still working live, you should be good. I mean, the good signs are the lines are longer when they're in the right views. So that's the important thing. And so Galapagos will still work with that. It just may sometimes, it looks like just a few lines are airing out, and it won't be able to create it. But yeah, I'm not sure why it's doing that. But like I said, it should work.
Thank you.
Yeah. Cool. Any more questions?
I have a question actually on trying to get the high-res image and doing a bake on the previous versions so that I can actually use the formulas and still use the image.
Okay, so I'm gonna share my screen really quick. So high-res image for bake. It is, get my screen up. So there's two things. All right, does everyone see my screen?
Yes.
Great. So once you have your view, I don't have any save views on this one. So we're gonna just turn all this off. Oh, hold on. We're going to just get a, we're gonna turn off, we're gonna just un-preview all this. So once we have that set up, there's also different setting. If we could always change the lens length as well. If this is just, if you want a more of a smaller lens, like I think the default for this is 50, which is a really wide lens. You can always right click on just your toolbar and it says show toolbar. And you can scroll down and there's a, or might not, oh, lens length. And you just click it. And I already have my default on here, but it'll appear like this. And you can just dock it right along, not along there. Or it could go right there, but sometimes you can get dock to dock, like I just had a second ago. But then it gives us some more options. So I always like something a little smaller, like a 50, or 25 or 17, something to get a little more dramatic. And we can set that up, the view that we want. We have our properties or our display, or we can just say, type in display properties. And that will have a little menu that comes up. It's actually, I have it docked right here because I use it so much, but a menu will pop up. And there you can control your background color, and we usually want it to be a solid. We can change our background to a white. Sometimes we have our ISO curves on. We'll turn that off. And you can also, you can see these little coordinates that we have in the bottom here. We can turn that off, so we can turn off like our grid, our world icon, so that little icon goes away in our axes. And then once you have that set up, type view capture to file. And we want something high, a little higher res. So I go for a 3200 pixel, 3200 by 2400. Since it's digital, you can probably go up to 96 DPI and say, okay. And a command prompt will come up and we'll save this here. And we can just say, save it. It'll take a second and then we'll see it says image successfully saved. Or we can do it as a shaded. You can also do it as an Arctic view. We do the same thing, view capture file, keep the same settings, and we can do that same thing. There it is. And so, and then when we bring up our menu, it should be a nice crisp image. Now sometimes, and sometimes you get these little shines. That's a, I'm not counting anyone against you if you have those, but if you want to turn those off, it's a, what is it? It's a render quality. Focal blur. sun. I don't want that. I don't know what. It's it's something that's buried within here, and I can't remember if it's in this or render, but sometimes it's distracting. I've had people comment that it's distracting. I haven't. Sometimes it is. Yeah, render. Yeah, so it's in the you have to probably right click on this and go to the rendering view tab. And when you do that, you get this Studio 360. You get this environment, and we can even click on it. It's like this little gradient. We're just going to click it and say no environment. So then when we go back to our view, we can go back to shaded. Oh, you know what? It was actually Arctic. And it should go away now. Yeah, so now it's a little cleaner. And if you want to save that view, like this is a view that you consistently use for this, you can click on this caret down, set view, and you can click named views. When you do that, you can do that save as. There it is. And it saves all the default, like all your settings. And then also one thing I want to talk about is this came up last class at the end. For your Grasshopper scripts, keep them compact, somewhat compact as you can, because when you export these, when you export the high-res image, you want to make sure everything's like a white background, 255. It will set the file path. We'll click OK. A little command prompt will pop up.
Yeah, because I kept getting an error.
Yeah, so when you get an error, it's because some of your components are just too far out, and it creates a too big of an image. So if you have this way down there.
I'm not. They're fairly compact, but it's the file size is just so large.
Yes, yeah, and it's because it's too big.
Okay.
And so sometimes it takes a long time, and it may give me an error for this. I kind of hope it does, because if it doesn't, it's going to be this huge PNG. And it will, yeah, see, there's an error. So what it does is it just created hundreds of it just pieced everything together and just created hundreds of these JPEGs.
Yes.
And so, yeah, that's why we just want to just bring things closer together so it doesn't create this, because this is just a huge mess now.
Okay.
So yeah, there's that.
Wow.
Yeah, yeah, it can. I haven't came across that one before, so yeah, sometimes it can get messy. So, any more questions? Great. Well, yeah, like I said, shoot me an email if you still have more questions or if something comes up. But if not, I will talk to everyone Tuesday or tomorrow.
Tomorrow.
Cool. Thank you very much, Sean.
Thank you so
Thank you.
much.
No problem.
I was so happy when you sent out the invite for this
Oh, good.
session tonight. I was
Thanks,
like, oh,
Michelle, for getting that to going.
Yeah,
Yeah,
thank
sorry
you.
it took up all your time, Michelle.
Oh no, it's okay. I learned from you guys. All right,
Yeah,
have
If you guys need more of this, just let me know. So that's what I'm here for. But thank you guys.
All right,
Thank
great.
you.
Thanks a lot. Have a good night.
Thanks, you too. Bye.